calculus.
Hey, other than seniors, other than my seniors in the room, did everyone get to vote on Kia? Did it work out? Okay, good. I heard it went smooth, so just hoping everyone got the chance to vote. All right. Hey, now for regular student council members, for like the other spots we'll have for all my juniors and stuff in here, those applications will be probably in the office by this afternoon, and then they'll be due by Monday next week. And I'll send an email to everybody, except for the seniors, so they don't get those emails. But that's if you want to run for a normal position for next year, not the student body pres position. So, yeah. So no, we're not having this video. So. All right, today we're going to take a few notes. I have a couple problems I've picked out that I want to go through that are like yesterday's, and I want to make sure that we know how to get through it. So make sure you have your notes out. Yeah, I only have a select few problems that I want to go through today. We'll start with the easy. We'll work our way up until we get to the final hard problems, and hopefully these make sense.
How many examples?
Let's see. 1, 2, 4, 5, 6, 7. Okay.
Bananas are the best. Bananas are the best.
Okay. Hey. All right. I have 6 problems I'd like to get through today. 6. The first couple are very easy. The last couple are kind of more difficult. I said like this section is significantly more. I wouldn't say difficult, but it's challenging in the form where it's not as straightforward as the last assignment. This assignment we're doing now has a lot of open-endedness in how you can approach the problem, and that's what I'm going to try to show you today, is that when you first look at the problem, how do you know which method to use? How do you know how to solve it? What are the methods we could do? And that's what we're going to talk about today. So I have a select few picked out, and then tomorrow we'll do a couple more that I want to discuss, and hopefully this will make sense as we go through it. So here we go. So first examples here. So again, we're on section 3.4. These are logarithmic equations.
There won't be a test over this though, right?
Yes, there will.
Why?
All right, logarithmic equations. The goal today was to talk about those different methods from yesterday that we talked about how to solve for missing values. Solve for missing terms. And yesterday we finished with a problem where I think I did a problem with like blood alcohol content, where I was trying to show you like a real life based problem that we use to actually find data that we need. Well, the goal is at some point today I want to talk about that problem that I did earlier like maybe a week ago or 2 weeks ago, where we talked about it was time invested. So I think I did a problem with, I think it was the pension fund.
I believe
number.
That was it.
And I want to talk about that today. So yeah, I want to talk about like something very, very similar to that, and why this is actually useful, like what we can use this stuff for. Okay, because that problem was almost perfect in its setup for what we're going into, like solving for a missing variable when it's in the power. Okay, so the goal today, we have a bunch of different methods of actually solving today. So the actual work that we talked about yesterday was like, one of the problems was, we talked about the properties of equality. That was one of the steps we talked about yesterday. That'll be one of my first ones I'll show you, and I'm going to show you different ways to do that problem. The other methods we had was we had a change of base formula. I don't know if I have picked up one of these today. No, that's tomorrow. So we'll do a change of base. The other ones we had were like factoring. That was a skill that we need to have. We'll do one of those today. And then obviously the last ones are the properties of logarithms. This is the new one today. Like, we're going to spend a lot more time today on this bottom one, because yesterday I went through an example of each of these. But the goal today is to look at these, and these are the ones I consider to be the challenging ones. Not difficult, but more challenging than some of the others. So properties of logarithms. But these are kind of the idea today, and all I want to go through is just some examples. That's all I want to go through today. I think 6 picked out. I don't know if I'll get to all 6 today, because we only have about a half hour or so. But I want to make sure that you guys feel comfortable. You have examples of each type today. You know what to do when you first look at the problem. But let's get started right in. So this is the first one I'd like to talk about. 2x equals 23. Okay. All right, this is my first problem that I'd like you to have. Okay? The goal here on this problem is to solve for x. There's two ways to do this problem. I'm going to try to hopefully show you both methods today, and hopefully it'll make sense once we get there. When you have this type of problem, you need to get the base that has the variable by itself. So like what I mean by this, e is the natural number, it's 2.7, whatever it is. But you want to get this part by itself because it has the variable up in its power. So if you ever have a problem, this would be like your first couple. To get this by itself, and this could be a number, it doesn't have to be e, it could be like 5 to some power, but you need to get rid of this number first because you need to get that base by itself. So I'm going to divide the 5 over. So this is e to the 2x, and I'm going to take 23 and divide by 5. Now, just leave it a fraction because the answers I'm looking for are the exact values. You don't, in theory, you would not need a calculator for these. So that it's not something I'm going to require that you type in things. The later ones, where they say solve for x, they might have a couple like near these last ones where it says, give me a decimal approximation, then we're going to be start typing stuff in. But first step, we move this over, and now there's two methods of doing this problem now. One method you could do by circle method, where you could change this problem to a logarithmic based problem. Okay? You could change this to a logarithm and actually solve it. The other method of doing this is where you use a property of equality to do this. So they will result in the same exact math, and that's why I want to show you like why there's two different versions, like one shorter than the other, especially on this easy problem. But this method will explain the concept of what we're going to use later. That's why I want to show you both, that they actually do give you the same answer. So on the logarithmic problem, that you do the circle method. You start with this is the base, you start with that, you circle around and you equal the power. So the log base e of the 23 over 5 equals the power. Like that's what it is. When you take a logarithm, it's log of the base of that other number equals the power. Because logarithm makes the power, and then the last step is divide by 2. So this is log base e, and what is, by the way, what is the log of base e known as?
12.
Natural log.
Natural log. Okay, it's natural log 23 over 5. And then your last step is divide by 2. So changing that to L of n means the natural log. It's the log of the natural number. So having log base e, you can try it as ln, and that means the same thing. But this is the final answer. That's what I'm looking for. That you got x by itself. You do not need to type it in a calculator or anything like that. Most people look at that and go, okay, that makes sense. That was stuff we've been doing, bless you, for the last couple days and last week and stuff. But there's a different strategy for this problem that will actually make more sense for the later problems. That you could just technically take the logarithm of both sides and actually solve it anyway. Or the natural log of both sides. So on this problem, I'm going to take the natural log of both sides because they have an e. So I'll just use the natural log. So natural log of e to the 2x, natural log of 23 over 5. And again, why I'm allowed to do that? That problem is a change of base technically. That I'm actually changing this base problem so that they have the same bases. And then I can actually solve it from there. So that's why I'm allowed to take the log of both sides. And when you do that, why I would actually write this is because this part right here, this is a logarithm to a power. You're allowed to drop powers up front using the power rule. So this is a 2x natural log of the natural number equals the natural log of 23 over 5. And the idea is that this part right here, that natural log of e is the number 1. Why that part's the number 1 is because the natural log of e means the log base e of e. And what you're trying to do is figure out what power you put on e, which is 1. So this part's a 1. So what we actually have here,
2 of x.
yeah, we have 2x times 1.
Boom. So 2x.
So if you can't see that, this is where I'm at right now. Okay, line is log 23 over 5. This turns out to be the number 1. We're going to take it times 2x, which the 1 can just go away. And then you'll divide by 2, because the 1 will just go away anyway. So your answer will be the same answer in the end, like this. all over 2, which is the same answer I had earlier, but it's just a different style, a different way of looking at that problem. Some people like it, some people don't like it. Some people look and go, that's more steps. Yeah, agreed. But some people don't like the whole circle method thing. Or if the problem's so complicated, there's too many things going on, it may be easier just to take the log of both sides and then just deal with the shortcuts later. Okay, are we good though?
Yes.
All right, that's the first problem. That was a properties of equality problem, and I mixed a change of base with it, where you take logs of both sides. Again, when I did this style, you're doing the natural log of both sides, but you could just take the logarithm of both sides, and it would still work out to be the same. Okay. All right. Moving on. Okay, where's my other? Here it is. Okay, the next style of problem.
It's a factoring problem.
Yeah, factoring. So, here's a problem that I'd like to talk about. E to the 4x plus 5e to the 2x minus 24. Okay, now why on this particular problem I would do the strategy I'm about to do is that
Factoring.
there's multiple items that have e and that have a power up in it. So on this type of problem, it's basically a factoring problem because there's a lot of problems here that have x's on them, and I can't just single them out like those last problems. So I could get the x by itself or the base by itself. So in this problem, like when I see it, this is literally kind of what I see in my head. I see e to the like x to the 4 plus 5x to the second minus 24. This is basically the style of problem that I see. You know, like this is an algebra 2 problem that you've had, where this is it's a trinomial. You could break it up by factoring, and where this is going to be plus minus because the minus sign in the back. You break up the x to the 4th to be x squared and x squared. You break up the 24 to be 3 and 8. I'll put 8 here and the 3 here. That way it makes 5 in the middle.
Coincidental.
And then you try to figure out what would make each of these 0. You try to see which would make each of these 0. Well, the idea is that you can't, this one will never make 0, no matter what you have, because you're going to square a number, and you're going to add it to 8, it'll never be negative, so I can never make that 0. But this one could be, because I could, you know, if the smaller this number is, I could subtract 3. Yeah, so the idea is that that's what we're going to look at. So, but the problem is, this is not my problem. Like, it's not with x's and squares and stuff. We have e's.
Oh.
And so we need to look at how that works. But noticing that this one will never be 0.
Never.
You have to understand that that cannot be 0. So we'll throw that part out, that there's no answer for that part of that problem.
Why?
Because no matter what, you'll never be able to plug a number and square it and add it to 8 to make 0. Because when you square something, it always makes it
What if it's
positive.
an imaginary?
So that's the problem. It's still not an actual number. It's an imaginary number. Don't get me wrong, but it's not a number that I can plug
Will
in.
we ever use imaginary numbers in this class?
Yeah, I mean we already have.
No, where have you been, dude?
That was
It's
the
a
beginning.
master
Long
Oh, that's
too.
probably
All right. Now, hey, let's actually factor this apart using the e's now, so we can actually get to the problem that I have here. So we're going to break this up. It's going to be plus minus. I'm still going to use the 8 and 3 idea because that still makes the 5. But breaking up e to the 4x, that's e to the 2x, e to the 2x. That's just how I break it up evenly. And now we already talked about that this cannot be 0. This answer does not exist for this particular parenthesis because e to the 2x, you're taking 2.7, putting it to a power, and trying to get negative 8. Because if you actually set this equal to 0, like trying to make this thing equal 0, because one of these has to be 0, there's no way that you could do that. You can't put a number in the power and make it a negative number. You can make it a fraction, but you can't make it negative. So that's why that problem doesn't actually have a number. So this doesn't exist. So one of the things is, you cannot take the logarithm of a negative number. It doesn't work. Because, you know, if I was actually solving this problem out, this is something we didn't talk about yesterday, you know, I set this equal to 0, so it's negative 8. And you try to do that whole circle method, the natural log of, so the log of base e, which is natural log of negative 8 equals 2x. This doesn't exist. You can't take logs of negative numbers, or log of base e. Maybe that's the better way to put it. Log base e of negative 8. This doesn't work, this doesn't exist, because you can't make a number negative by putting a power on it. But this problem over here could, because if I set this equal to 0, I get this. That's what I get when I set that equal to 0, I can move the 3 over. And now I can do the log base e of 3 equals 2x, which this is the natural log of 3, equals 2x, and then divide by 2. And this would be the actual number I could plug in. And I can check to see if does that work. Because on these types of problems, you do have to check. You do have to plug it back in and see if it actually works and all that good stuff. But I just thought it was kind of interesting that on the style of problem that you can do here. Questions, comments about these problems? Okay, let's move on. We did factoring. Let's do these whole solving logarithmic problems.
Logarithmic?
Logarithmic.
Oh, really?
Yeah.
I pronounced it wrong my whole life. Logarithm. No.
All right. Okay. What time are we out of here?
51.
What? 51. Okay, we got a
Finish them all out.
I can possibly do 2 of these.
We're about running out of time this one.
All right. Here we go. Okay. These are my last 2 today. So, last 2 problems. Okay, these are going to be very similar in nature, like the way that I'm going to solve these. So these are the new ones I wanted to get to today. These are the ones we didn't discuss yesterday. Log base 2 x minus 1 plus log base 2 x plus 1 equals 3. The goal in this problem is to solve for x that would actually make 3. And again, when we actually do these, you do have to plug the numbers back in and see if they work. Just kind of like the last one. We'll do the whole checking thing tomorrow to check does it even have an answer, does it not. Okay, there's 2 ways to do this problem. I'm going to show you both. The way that I see this problem, the way that I would work this problem. Now, I kind of warn you, these problems are definitely more challenging than the previous problems. Okay, just because the amount of work we have to do to solve these. So I picked up 2 today, and these are the last 2 problems for me today, okay? So what I always recommend, if you can, move all the logarithms to one side. You only have to do that if there's like single numbers by themselves, single digits. If you don't have single digits like this, you don't have to move them to both sides. You can keep them on either side of the equation. We'll see one of those, that'll be like my next example. But on this case, I have all the logs on one side. Now this one, you're going to need to use the properties of logarithms. What is the property when you add 2 logarithms together? How can I combine that to make 1 logarithm?
Multiplication.
Multiplication, yeah. So this is 1 logarithm, base 2, where the items that they're actually adding here, you can actually multiply these together. Because you can make it 1 single logarithm. They were adding, but you combine them down. That was the homework that you guys were just doing on this page 421. And now, at this point, now I can actually solve this problem out, because now I can take this logarithmic problem, change it back to exponential, and actually solve. So this is 2, that's the base 2, to this power equals this mess. So 2 to the 3rd power equals x minus 1, x plus 1. And so this turns out to be 8 equals x minus 1, x plus 1. And now all I have to do is solve that problem. And that's an easy problem that you guys have actually looked at in Algebra 2, how to solve those. So hopefully that, now getting you to this point, now we have to go just a couple more steps. But again, the part that always gets people is like, how do you know that you can combine this back to multiplication? Because they were the same logarithm, and they're being added together, so you can always combine to make a multiplication. That was the product rule. And now we're here. I'm going to FOIL this out, set equal to 8. So this, if I FOIL that out, that's x squared minus 1 equals 8. If I actually FOIL first outer inner last, so that would be x squared minus 1 plus 1x. Those cancel and then negative 1. And so to solve, we could add the 1 across and take the square root. So it looks like I have 2 specific answers on this problem, plus or minus 3. So, but knowing that I could solve it that way, it's kind of unique. And then I would have to check. I would have to actually take positive 3, plug it in, take a negative 3, plug it in, and see if it works. One of those numbers is not going to work. Okay, can anyone figure out which one of those two won't work?
-3.
-3. Yeah, because if you plug -3 in, you're gonna get negative numbers, and you can't take logarithms of negatives. So that one's thrown out. So really, the only problem that we'd actually have to check
It's positive
would
3.
be +3. This would be like the only one in theory that you could potentially use. And to see if it actually would give you 3 out. Okay, questions?
I was gonna fix it.
And by the way, it does work if you actually plug it in. We'll look at that tomorrow.
Yeah, it does.
Oh, okay.
It does.
Which one? When do we find out about student body correction?
Possibly as early as tomorrow. So,
What are the
because I have to do the count today after school.
So isn't it?
Wait, is that automatic count?
Yeah, but we have to make sure everything's squared and
Mr.
everything
Ward, like
correctly.
today after school in your room,
No,
Could we help?
but will your room be unlocked?
no.
If I were a senior, could I help?
What?
If I were a senior, could I help out?
So,
If I were to.
Okay. all right, we're good on this one? Okay, last problem of the day. Here it is. Last problem, I'd like you to have this one written down. Here we go. Last problem. And again, I consider them more challenging. They're not difficult. They're longer process. Okay, all right, here's my last problem. This is one that I kind of warned you of. Okay, log
Is it frightening?
of 2x minus 1 equals log of x plus 3 plus log 3. All right, this is my last problem of the day. Last problem. Notice that both sides have logarithms. There's no single digits by themselves. I don't need to move everything to one side. I don't need to move all the logs to one side. I can actually just solve this problem by leaving the logs where they're at, but just combining like this side down to 1 logarithm, it's already there. Combine this one down to 1 logarithm, and then I can show you the shortcut, which is a change of base shortcut. Okay, so it's actually a property of equality as well. But on this one, this side, I'm going to leave it alone. It's already 1 logarithm over here. The base on it is base 10, so I don't really care about that. On this side, I'm going to combine this down to 1 logarithm. So this is log, and I'm going to multiply those two things together. That's 3 times x plus 3. And it doesn't matter the order you put it, it's just going to be the same numbers anyway. So that's combining that down to 1 logarithm. And the reason why I can do that is they're being added, so I can just do that. If they were subtracting, I would have to divide these. So you make a fraction right here. And now at this point, this is the weird part. If you have logarithms on both sides and no single numbers, okay, you can cancel out the logarithm on both sides because it's a change of base. They have the same bases, they're base 10s. And so since there's just logarithms on both sides, you're allowed to cancel them. And so what I'm left with is this. And now this is an algebra 1 problem. And you can go ahead and solve from there.
Pretty tough one.
So this is 2x minus 1 equals 3x plus 3 or plus 9. Subtract this over, add that across. So this is negative 1x equals 9 plus 1, which is 10. So this is negative 1x equals that. So x would be a negative 10. And then you'd have to check, does that work? You'd have to plug it back in and see if you'll actually get the right answer. Well, the problem is, this problem might not have a solution. If I plug negative 10 in, will that give me things I can take logarithms of?
No.
No, so this doesn't have a solution. So what this is saying, so there's no solution on this problem because there's not a single number that I could plug into this problem that would potentially make the left and right side equal each other. It's not going to happen. Even though, it gave me an answer like negative 10, but you can't use negative 10. Those are things you have to double check.
No solution.
Okay, yeah. So we'll look at problems tomorrow where they actually have solutions or multiple solutions. That's what you go through. But you needed to see that today, that you can have problems that don't have solutions, and that's what makes this stuff difficult. Yeah. Okay, all right, we're done for the day. Very nice reading.